Hi everyone, welcome to the next video of our introductory sessions to embedded software development. For this session I would like to talk about interrupts and what do they represent in embedded firmware. We have interrupts that can happen on external event, and when this event happens, an interrupt service routine is being executed on the board. In particular board, we can use any pin except D2 and A5 as an interrupt pin. And the syntax to attach interrupt to a specific pin is attach interrupt with the following parameters, which are pin, as I mentioned before, all except D2 and A5. The second parameter is a name of parameterless and void function that is going to be executed. The third parameter is mode, which can have following constants: change, rising, or falling. Let me just show you how to interpret those modes. So if you have a pin, so let's say this is a time and this is a value. So this is time and this is value, probably in some voltage, but the value can be high and low. So let's say this is low and this is high. So if you have a signal which is low on a specific pin and becomes high and stays that way, this is rising, this here, because it goes from low to high. If you have high signal and then falls down to the low, this is falling. And change is any of these two. It can be either this or this, because the change means any change from high to low or from low to high, any signal change. But basically you have only two options, rising and falling, and change can occur two times in the event, for example, of a button press. When you press the button, it goes from high to low and go back to the high when you unpress the button. So you have a two times interrupt in if you chose mode change. The priority is the number, usually by default it's number 13, and the lower value means higher priority. In embedded development, in microcontrollers and so on, you can have a collision of events, collision of interrupts that need to be resolved, and they are usually resolved by this priority. If you have a interrupt at the same time, the highest priority, I mean the lowest number, will be selected as interrupt routine being executed. And you also have a sub-priority, which is optional. Even if you have the same priority, the sub-priority will allow you to have a more fine grade priority decisions for this. In this demo, what we're gonna do now, we will connect LED resistor as we did in the previous video, and we will toggle the LED state not using reading of a button, rather using interrupt. And to do that, let's create ourselves a new Visual Studio Code. I have a previous code from last session, but I'm not gonna, I will just clean it up and start from beginning. But here you can actually see what we did by reading manually from previous video. The previous video is going to be in description, so you can take a look here. So let's have empty state there. Okay, I'm gonna use the LED on D3, const int pin button. I'm gonna set it to D2 as it was before. And then I'll create myself a variable, volatile, bool, and I will call this iState. And I'm gonna set it to low. Just a tiny bit remark. The volatile variables in this case, it's a bit more complex. Simplified, it would be that the volatile variables do not include all the security checks for the access to the memory. For example, if you have a longer variable like a string and you have a processor writing some values into that memory space, if this space is volatile, it can happen that reading and writing can occur at the same time, physically same time, and you can get mixed data. Part of the string is going to be a new value and the other part of the string is going to be old value, just because the variable is volatile. It doesn't wait for the writing or reading process finishes, so the new one can start. And reading and writing to volatile variables is much faster, and this is why the volatile variable is here used. And I'm going to use this iState variable as a flag that interrupt occurred in the first place. Then in the setup, I will declare myself the pins with the pin mode, pin LED is going to be output, and the pin mode for the button is going to be, as we did in previous video, pin button is going to be input pull up. Button is going to be input pull up, and then I will attach interrupt. The first parameter, as I mentioned before, is the pin button, is the number of a pin. And then second parameter is the name of the function. Let's write here toggle, interrupt service routine. I didn't write it. I will do this after. And this next parameter that I need to choose is the mode, and in this case let's use falling, and I will not use priority and sub-priority because they are optional. Because I only have one interrupt, it doesn't matter if I'm gonna have many of these. And let's create here void toggle, and inside the toggle I will set iState to negative iState. So the idea of interrupt service routine is that it has to be as short as possible. In this particular case, what I'm doing, I'm just raising a flag that state has happened. And because this is a volatile, it will not take time. You need to be aware that if you have a loop and interrupt happens, this interrupt will pause the loop. An idea of having a flag and general idea of interrupt is just to notify the main loop that interrupt has happened. And in my case, we did this with iState. I stands for obviously interrupt state, that the iState flag has raised, and you can then in the loop we will check if the interrupt actually happened. Not in the interrupt service routine. Obviously, we could have, for example, in code we could have right here digital write pin LED high or low, but this is wrong, because this digital write takes time to execute, and the idea is that the interrupt has to be as short as possible. And in the loop, what I'm gonna do, digital write, pin mode, pin LED, and I'm gonna set it to I state. This will work. We can try it, but before, let's create a device. Here I have my board, button, resistors, and some wires, and of course the LED. I'm gonna create the circuit. It's pretty much the same as the one we had before. Like before, I'm just using the ground for my vertical part of the breadboard, and then the LED on the ground, and here I'm gonna connect the LED to in the code it's on a D3. Let's put it on a D3 here, and of course button. Also, one side of the button goes to the ground there, and the other side goes to the D2 here. There we have our circuit set. I can plug in the board and start flashing Cloud Flash. Give it some time. There, my board is flashing, and we can now examine the behavior. If I would press the button, you can see it is toggling the state. Also, I do have that problem with, again, sometimes the button is not perfect and it can register 2 interrupts and the LED will just flip states multiple times. But in essence, it works pretty much the same as the version without interrupt. Again, a bit flickery and not consistent. And let's fix this. Of course, we need to introduce some delays. But what I don't like here is I want a clean slate here, because this state is being used to toggle this LED state, which is not a good idea. In order to fix this, I'm gonna create myself a variable, bool LED state. I'm gonna set it to true. You can see that I'm mixing lows and trues and zeros and ones, because they're all the same value. It's actually 0 and 1. So don't be confused by that. And then the state, I state, I'm gonna set it to true, which is the best practice. Just raise the flag. Don't use the flag, raise it. And then in the loop, I can actually remove this. I'm gonna check if I state, so if interrupt happened in the first place, I'm gonna delay the same reason we did before, delaying for this flickering. And during this time, even if interrupt happened, all that interrupt routine, so this is interrupt service routine, during these 250 milliseconds, even if interrupt happens multiple times, all that it's going to do is just set the flag back to the true. And in the previous case, even if interrupt happened multiple times, it will flip the value and we will have the wrong value for our one interrupt. This is why it's also better to have just raising the flag, because this is only setting to a constant value, not flipping or anything else like this. And then after this delay, I will do digital write pin LED. I'm gonna set it to LED state, and initially this is low. Sorry, it is true. So this will initially turn on the LED, and then after this I will toggle the LED state. LED state equals to negative LED state, and only at the end I'm gonna lower the flag of interrupt state. So I state equals to false. And now let's check it on the board. Cloud flashing. You can actually see that this works pretty standard and normal, toggling the LED state. So this is using interrupts. The previous video used just a plain reading of the value of a digital pin. In this case, this is actually the basic of computer mouse. Just imagine that's how precise they have to be. For example, you have a computer mouse, you press a button. If you're a gamer playing FPS, you press the button and this button registers 2 times. That will be awkward. So this filtering of multiple presses, even that button is not perfect in a gamer's mouse. They also have to do some delay. This delay of 250 milliseconds that we had is way too much for any game. This would actually mean that once you press the button, the reaction will happen 250 milliseconds after that. So this is not a case for a computer mouse. But in essence, the same mechanism, the same algorithm, the filtering of false values is something that is also happening in a mouse. And this concludes this video about interrupts. Interrupts are widely used and are very simple to implement. And I encourage you to follow these tiny instructions to make your solution more responsive, more optimal by using interrupt techniques. Thank you and see you next video.